All right, Algebra 2. Today we're going to be talking about simplifying radicals with variables. I was going to do multiple videos on this, but I think it's short enough that I can do one. So if you're looking for specific examples, make sure you scooch forward in this video. I'm going to do all of them here. Here we go. Yesterday we talked about how to simplify variables essentially with numbers inside. Now what we have to do is talk about simplifying radicals with variables. So the first thing I want to talk about is the difference between exponents and normal things, like normal numbers, I mean. So for instance, you don't have to write this down. When I have something like 4 times 3, and I know that comes out as 12, great. I know that this 4 is a perfect square, and when I take that square, I end up with a 2, right? So I can basically take this square root of 4 and I get a 2 from that. Okay, cool. I think most of us understand that. Most of us are cool with that. I think we're all good. We don't need to freak out about that. But now I'm going to show you something else. If I were to take the x squared, if I were to take the square root of x squared, I would end up with x. How did I get there? Okay, well, let's talk about the square root of 4. And again, don't write this down. The square root of 4 is 2. And what that means is 2 times 2 is equal to 4. The square root of 9 is equal to 3. What that means is 3 times 3 is equal to 9. That's what the square root means. So I'm going to look at this x squared, and I'm going to tell you x times x is x squared. Where did I get those numbers? Remember, if there's nothing in the exponent position, there's a 1 there. I can literally add those together. So x to the 1 times x to the 1 is the same thing as x squared. So if square root of 9 is 3, and I have 3 times 3 is equal to 9, that means the square root of x squared is x, because it takes me x times x to basically get to the x squared. So square root of x squared is x. Pretty straightforward. It's kind of tricky, but when you see this, the pattern that emerges, it's going to get a lot simpler. So with that said, let's check out number 2, x to the 4th. That's what x to the 4th looks like. X to the 4th looks like x times x times x times x. And if you don't believe me, there's a 1 up here, there's a 1 here technically, a 1 here, a 1 here, add them up, and that's 4 x's. So it's x to the 4th. So we're multiplying 4 x's together. When I take the square root of that, you're going to end up with something funny. But I'm going to go back real quick, and I'm going to break it down one little step at a time. So I'm going to go back to this page. You don't have to write this down. I just want you to pay attention. So the square root of x to the 4th is what? Well, I'm going to start by doing this. I know that the square root of x squared is x to the 1. Okay? So check out this thing right here. I'm going to break this apart. I know that x squared times x squared is the same thing as x to the 4th. So I can basically break this as apart as x squared, square root of x squared times the square root of x squared, and I end up with x times x, which gives me x squared. So the square root of x to the 4th is actually x squared. There's a pattern between this number. Check this out. The square root of x to the 6th is actually x to the 3rd. And why is that the case? Because x to the 3rd times x to the 3rd equals x to the 6th. So what's the terms I have to multiply to get x to the 6th? The same term? It's x to the 3rd. What about square root of x to the 8th? Now we're dealing with x to the 4th. Why? Because x to the 4th times x to the 4th is the same thing as x to the 8th. So you should see a pattern there. Notice when we're dealing with exponents, you simply divide by 2. If it's even, you divide by 2. So the square root of x to the 16th would be x to the 8th. And I did that quickly by dividing by 2. And how do I know that? X to the 8th times x to the 8th is, in fact, x to the 16th. Bravo for us. With that said, I'm going to go back to these other problems. So what is the pattern for even-numbered exponents? Divide by 2. Dividing by 2. So check it out. Square root of x to the 6th, x to the 3rd. And why is that the case? X to the 3rd times x to the 3rd equals x to the 6th. B, square root of x to the 8th. That is x to the 4th. What did I do? I divided that 8 by 2. And now what I have is I have x to the fourth. And how do I know that? Because x to the fourth times x to the fourth is x to the eighth. Awesome. Now let's talk about odd numbers. When I have my odd numbers, here's what I get. I'm going to show you how I break this apart. I subtract 1. What do I mean by that? I subtract 1. I subtract 1. Mister, I don't get it. So I subtract 1 and I split it apart. So this is x squared, or x to the cubed, or sorry, yeah, x to the third. And so what I do is I subtract 1. 3 minus 1 is 2. There's my 2, and there's my 1. If you were to put this together, you would have x to the third. But since it's an odd number, I can't do much about it. So now I can split this up, and I have the square root of x squared times the square root of x to the 1. The square root of x squared is x, and I cannot take the square root of x to the 1. It just stays like that. So this answer ends up being x square root of x. And if you lost on that, don't worry, we're about to do it again. Check it out, x to the fifth. I'm going to break x to the fifth up as x to the fourth times x to the 1. Now see that? We already answered x to the fourth earlier, but now I have the square root of x to the fourth times the square root of x to the 1. There is no square root for the x to the 1, so that's going to be stuck over here. But the square root of x to the fourth, using our even numbered pattern, is x squared. And we have ourselves the answer. All right, I'm going to basically, this is the lesson. Maybe I'll do 2 videos and then show these over here. Yeah, I'm going to do 2 videos.